the key here to the pre-quiz. So our first one is dealing with what's a positive angle, what's a negative angle, and you can draw a diagram to represent this. So if we have positive angles, remember positive angles the open counterclockwise, and they always start on that vertex is at the origin, and your initial side is always on that positive x-axis. Alright, so positive angles open counterclockwise, so positive angles open this way, and so it could end right there. Alright, so that's a positive. Negative angles open down or clockwise, so I would just show the arrow, have my arrows pointing down, so that lets the reader know that it's negative. Okay. The second one here, we're solving, finding complements. So we have two angles, and we're finding that are complements. We want to know what are the values of this angle, 5x minus 1 and the value 2x. So we're not just finding x here, we're going to plug x back in after we find it. So remember, measure of angle 1 plus measure of angle 2 equals 90 degrees, right? That was what it means, complements. So 5x minus 1 plus 2x equals 90 degrees. So I add these together, I get 7x minus 1 equals 90. Add 1 to this, plus 1 equals 91. So 7x equals 91. So x equals 91 sevenths. X equals 91 sevenths. I could do that on a calculator and figure out what that is. So that is 13. So now that's my x. So now I can plug that back in. So 2 times x is 26. So one angle, we'll say measure of angle B equals 26 degrees, right? It doesn't really matter that I put A or B. I just labeled them one angle. Maybe I'll label this for the people that are just reading the answer key. Let that be angle A, let that be angle B. So that means angle A would have to be 63. And we can check that. 5 times 13 is I don't know off the top of my head. So 5 times 13 is 65, and 65 minus 1 is 64. So good thing I checked, right? Because I put 63 there. That's actually 64, if I could add correctly. Okay, so those are my two angles that I'm finding. Okay, the next one is supplements. Supplements means we're actually going to be adding up. So let's put an addition sign there. And the M just stands for measure, so measure of angle A, measure of angle B. Add them up, that equals 180. So let's go ahead and plug those in. 3x plus 5 plus 5x plus 15 equals 180. Add our x's, we get 8x. Add our regular numbers, we get 20 equals 180. We can subtract 20 on both sides. So we get 8x is equal to 160 divided by 8, x equals 20. So then we can plug it back in. Measure of angle A is equal to 3 times 20 plus 5, so that's 65. And then we can add that up, right? So that's 110, or 115, sorry. So measure of angle B should be 115. And again, I just used A and B just to identify what those angles are. And then we can check this, right? 5 times 20 is 100, 100 plus 15 is 115. So this time I actually wrote the right number. Okay, let's take a look at some more. Okay, so here we're converting into degrees, minutes, and seconds. And remember, you can kind of think about this as like hours, minutes, and seconds. Okay, because there's 60 seconds in 60 seconds is 1 minute, and 60 minutes is 1 hour, or 1 degree, right? So that's kind of what we're doing. We're putting into degrees, minutes, and seconds. So how many degrees are in this? 22.0250 degrees. Well, there's 22 degrees in there. Okay, and then there's also 0.0250 degrees. Well, how many minutes is that? Well, if I take that and I divide that by 60, that's going to tell me how many minutes are in 2 or 0.0250. So actually I don't want to divide it by 60, right? Because I actually get a really small number. Because I want to switch this, so I don't want to divide by 60. I actually want to multiply by 60, right? Because there is 60 minutes and 1 degree, so this is 0.025 degrees. And so I'm asking how many minutes are in there. So this is actually I want to times by 60, and I actually don't need this plus sign here. So I want to actually times by 60, and that kind of makes better sense, right? Because if this was 1 degree, that'd be 60 minutes, right? So this number I don't want to divide by 60 because then I'll get a really small number. Okay, so that's 1.5. So that's 1.5 minutes. So now I have 22 degrees, 1.5 minutes. So now I'm going to take this 0.5 of a minute, and how many seconds are in there? Well, how many seconds are in 1 minute? There's 60. So I'm going to times this by 60. And that equals 30, right? So 30 seconds. So now I want to switch this to 30 seconds. So now we have 22 degrees, one minute, and then 30 seconds. So the parentheses there. Okay, so if you have a decimal here at the very end of seconds, go ahead and round that. Okay. And on this second one here, when we're converting to decimal degrees, right, that means we're changing everything to degrees. So how many degrees are in 77 degrees? Well, there's 77. Right? How many degrees are in 12 minutes? So that's when I got to take the 12 minutes and divide it by 60 this time. Okay, so I'm going to divide by 60 this time because I want to figure out how many degrees are in 12 minutes. Because if I multiply this, that would mean I would have a really big number of degrees, but I can't get much bigger than 77 degrees, right? So I divide that by 60, so that is 1/5, right? Which is 0.2. So we got 77.2, and then I can go ahead and take my 0.9, and I want to find out how many degrees are in 9 seconds, right? So this time I don't want to divide by 60 because that would be finding how many minutes, right, are in 9 seconds, or in 9 seconds, not 0.09 seconds, 9 seconds. And so I'm going to divide this one because I want to find out how many degrees. Well, there's 3,600 degrees, or 3,600 seconds in 1 degree. So I'm going to take 9 and divide it by 3,600. Okay, so we go ahead and divide that, and we got, we'll do this. We got 0.0025, and so here 12 divided by 60 was 0.2. So if we add all these together, right, pretty much this 2 is just going to go in the spot of the first 0 over here, so we get 77.2025, right, because this 2 is basically going to go right here. Okay, and so that's our answer, and it's in degrees, so it's called decimal degrees because we have a decimal. But you could say just degrees form, that would be fine. Okay, alright, here we go, we're solving right triangles, so we haven't had much practice on this yet, but we will in the next class period. Okay, so we have solve a right triangle, so hey, why not actually put a right triangle on the screen, right? So let's do that. That's good enough. Okay, and now we have these angles and sides, so let's go ahead and label this. It doesn't matter how we label this, you know, A, B, C. We're probably all going to label this right triangle C, or this right angle C. So that means opposite of all these angles are the lowercase of them, right? So if I put C at the 90 degrees, opposite that, the hypotenuse is going to be little c. Opposite of angle B will be little b, and opposite of angle A, or side angle A, is side A. So that's the only thing you have to be careful about. You can't label them all however you want to. Once you label the angles, then opposite of those have to be the lowercase of those, okay? So just be careful on that. Okay, so now we can label these. Now here's a little trick, right? Because that's 50 degrees and 30 seconds. We want to switch that to decimal degrees form. Okay, so how many degrees are in 30 minutes? Well, that is 0.5. 50.5, right? So go ahead and switch that first. So now this angle right here, measure of angle A is 50.5 degrees. Okay, and then we got little a. So we have this one, 50.5, and we have this side as 700, 480. Okay, so we need to find angle B, and side B, and side C. Okay, so we want to find all six, right? We want to find measure of angle A, measure of angle B, measure of angle C. Some of these we already know. And then we want to find side A, side B, and side C. So A we already know is 50.5. Angle B we don't know yet, but we can find that pretty quick. C is 90 degrees, and A is 748. So B we can find, right, because we know a triangle adds up to 180, so we can go ahead and take 50.5 and subtract 90 from that. And so we get 51 if we add 0.5, so it's going to be a 0.5er. And then that's 51, add 9, that's 60, so 39.5, because that needs to add up to 90, so that adds up all to, so I can do that. So let's just do 90.0, sure, minus 50.5 is 39.5, right? So that is our measure of angle B. So now we got our angles all done. So now we can go ahead and get to work on these sides. Now you can go ahead, because even though I have a decimal here, because I didn't have to round this 39.5, you can go ahead and use this angle and use the angle A, so it doesn't matter. Anytime you round, okay, you really don't want to use those numbers that you round to find anything else that you need. Usually just use your given information. But if you come to an answer like I just did at 39.5, because I didn't have to round that, I can go ahead and use that information. Okay, so I want to find side B. So let's just go with the given. So we're given angle A and side A. So what is the relationship to B in relationship with angle A? So that is adjacent, right? So adjacent. And what's given, the side that's given? So side A in relationship to A. That is opposite, right? So we have adjacent and opposite. What trig function deals with that? Adjacent and opposite, that would be tangent, right? Because tangent of angle A specifically, is opposite over adjacent. And our opposite is A, and our adjacent is B. And we know our angle A is 50.5. And we know our opposite is 748 over B. So here's a little bit of a tricky one. Tangent, usually you use tangent a lot in the word problems or the application problems. That's because mostly you're trying to always find the length of your hypotenuse, right? How big is your hypotenuse? So this time is a little bit tricky. Basically, the B and the tangent are going to switch places, because you're going to multiply both sides by B to get rid of that B from the bottom. So this is going to cancel out. So I need a little bit more room here. And so I get B tan of 50.5 is equal to 748. And then I want to divide, so see how they just kind of switch places there. And really, you could have just flipped the fractions, right? Because if I flip one side of the equation, I can just flip the other. Okay, so then we can go ahead and find B. Okay, so we go ahead and put that in our calculator, and we get B is equal to 616.6. Okay, so I did 0.6 because this is a 0.5. So you could do Pythagorean theorem here to find C, right? But we're not going to do that because I rounded that to 0.6. So I left some decimals off, even though it's in the end I'm going to probably do the same type of rounding when I find C. But just to keep those numbers as pure as possible, we're going to go ahead and just think about what trig function can get us C. Okay, so for C, we're going to do, what is A in relationship to C? That'd be the hypotenuse, right? always identify the hypotenuse to begin with, right? So I could think like, yeah, angle A and C inside C, that's adjacent because it's connected to A, but let's always identify the hypotenuse first when you're dealing with any of these triangles. So C is the hypotenuse. Now, what's given? Side A, 748, what is it relationship to A? That is opposite, right? So which trig function deals with hypotenuse over opposite? Well, that is going to be sine, right? So sine of A is equal to opposite over hypotenuse, which is equal to, I'm going to go ahead and cross this out, and we'll redo this one. We'll finish this one. I'll extend the page. And opposite is our A over, and hypotenuse is our C. Well, sine of A, we know, sine of A is equal to, sine of A is 50.5. So 50.5. And opposite over hypotenuse is A over C, and our A is 748 over our C, and our C is our hypotenuse, and that's what we're trying to find. Okay, so now I'm going to have to do some more work, because basically the C and the sine is going to switch places, right? Because we're going to multiply by C on both sides, and these are going to cancel out, and so we get C of sine 50.5 equals 748. So now we're going to have to divide by sine of 50.5, sine of 50.5, and so C is equal to 748 over sine of 50.5. So we get C is equal to 969.4. So that is equal to 969.4. So we can go ahead and label all those, 969.4 and 616.6. So you could use Pythagorean theorem. All right, you could do a little check right now. Which one has to be the biggest side? That's C, right? Is C the biggest? Yes, so at least we're on the right track. Now I could square each one of those. So I could square this, I could square this, and then add these two together, smaller ones, and see if they come close to that 964.8. And they should come really close, right? Because we rounded, so it shouldn't be exact, but it should be pretty close. So that's kind of how you can check those. Okay, so those are our 6 answers. Oh, and our angle B was 39.5. So we have all 6 right there. Okay, now let's go ahead and find sine, cosine, and tangent of angle A from the previous problem, so 50.5, and round all answers to the nearest hundredth. Alright, so let's go ahead and do this. We wrote it there for you. So we're going to take sine of 50.5. We're going to take cosine of 50.5. Make sure your calculator is in make sure your calculator, whatever, tangent all the way up, is in degrees, right? Because we're in degrees. Okay, so sine of 50.5 is 77.16 degrees. Or not degrees, sorry. Erase that, degrees. Not degrees. Not even degrees. It is not even that. It is literally 0.77. It's 0.77, right? Because remember, sine and cosine both have to be between 1 and -1. For some reason in my head, I decided to move the decimal over 2 places already. I don't know why. Now let's go ahead and take cosine of 50.5 degrees. Okay, so that is 0.64. So cosine of 50.5 is 0.64. Now let's find tangent. Okay, and so tangent is 1 of 50.5 degrees is 1.21. And we can know tangent can be anything, right? From negative infinity to positive infinity. Okay, so those are our sine, cosine, and tangent of angle A. Okay, now we're going to find the 6 trig function ratios of the terminal side of an angle that goes through the point negative 24.7. So we're on a graph. We have our initial side, and it's opening up and going through this point negative 24.7. So I could graph this maybe 5, 10, 15, 20, 25. So, and then 5, 10. So this is 5, this is negative 5, this is 10, this is negative 10. Let you know what I'm counting by, right? And then so up here would be negative 24. Oh, comma 7. Right, that's my point. And now I can graph. And it goes like that. Let me do a better graph. So there's my initial side on the x-axis there, and my angle opens up through that point, right? So my angle goes from here over, right? That's the angle I'm looking at. But I want to find the 6 trig functions, which is sine of this angle, and you can label anything you want. You can label A, you can label B, you can label it theta, which I usually do a lot. So sine of A is opposite over hypotenuse. But from before in the first section, right, isn't it y over our r? Right? Sine of A is, I just wrote that down. Here's cosine of A is x over r, and tangent of A is y over x. And so that's what I want to find. I want to find my x, y, and r. So x is equal to negative 24. Y is equal to 7. Now r is a little tricky. I got to square root my x squared plus my y squared. So I got to take 24 squared and add 7 squared. So my r is equal to the square root of whatever 24 squared is. I'll figure that out. And 7 squared is 49. So you always add them, even if you have a negative in there, you're always going to add these numbers, right? This is kind of the absolute value of a complex number too, or the Pythagorean theorem, right? So 24 squared is, negative 24 squared is 576. So we add that to 49, we get 625, and the square root of 625 is 25. So now we have our x, y, and r. And so now we can go ahead and do our trig functions. So sine of A is equal to our y over r. So that'd be 7 over 25. Cosine of our angle is equal to x over r, so negative 24 over r, which is 25, and tangent of our angle is equal to y, which is 7 over our x, which is negative 24. So we get negative 7/24. Now here you can see we're in the second quadrant here, so that means only sine and cosecant are positive, so we can see that cosine and tangent are both negative. Okay, now we can go ahead and do this one. Find if tangent of theta is 7/5, what's secant of theta? Here you're going to have to use, that's a theta, not a circle with a bow tie. Okay, so we always want to look at what are we given, what trig function are given, what trig function we're trying to find. So we have tangent and we have secant. So we look at all our identities, you know, your Pythagorean ones, what sine equals, your reciprocal ones, your quotient ones. And we notice that in our Pythagorean ones, we do have a formula that says tangent squared of theta plus 1 is equal to secant squared of theta, right? Because I have tangent, I need secant. Well, here's a formula that has both of those trig functions in it. Another way to represent this is tan of theta squared, so I don't square my theta, right? I'm squaring tangent. Plus 1 equals secant of theta squared. Right? So I don't know secant. I'm trying to find secant, right? But this is secant squared, so how can I get rid of that squared here? I square root both sides. So that means it's not, this answer is not tangent of theta plus 1, right? You can't square this. You can't square this and square this, right, and add them together. That's not how that works. Okay? So I get the square root of tangent squared theta plus 1. That will equal secant. Now tangent is 7/5. So that's 7/5 being squared and then adding 1 to it and then square rooting it. That's my secant. Okay, so that's 49 over 25 plus 25 over 25, because isn't 25 over 25 1? So that's adding 1, and then after I add it, I have to square root it. So now I can go ahead and add my numerators, right? Because they have common denominators, which that 25 bomb is really nice, right? Because when you square root that, you'll get 5. So 49 and 25 is 74, right? So then when I square root this, that's my secant. And here we get square root of 74 over 5. The square root of 25 is 5. and then I don't know which quadrant I'm in, so I'm going to have to put a plus or minus because I square rooted that, right? So there's my answer. Can't break down 74 at all there, so we're good. So there's our answer. So there's 2 there. Okay. All right. Now determine if sine of 2/3 is possible. Well, remember our range, sine and cosine both go from -1 to +1. Right. So does this answer fit in between the other 2/3? Yes. It's possible. Now find the exact value of cosine of 240. So several ways you can do this. When it says no decimals, that means no calculator. So no calculator. Okay. So here I want to take cosine of 240, which you can use to figure out which quadrant it's in. All right, so 240 is down here. So that means I'm going to find cosine. What's cosine over here in the 3rd quadrant? Maybe I shouldn't have wrote that yet. So down here, quadrant 3. So cosine is negative. But what you can do is you can find the reference angle, right? How far is it back to 180? So if I take 240 and I subtract 180, I'm finding my reference angle, right? My reference angle is 60 degrees. So my reference angle is 60 degrees. So I look at my chart where it says cosine of 60 degrees. What is cosine of 60 degrees? Well, cosine of 60 degrees is the same as sine of 30, and sine of 30 is 1/2. So cosine of 60 is 1/2. But since I'm in quadrant 3, that means cosine of 240 is actually -1/2. And as you look at these a lot, you'll start seeing of getting these pretty quick, because when you look at 60 and 30 degrees, your answers are either going to be 1/2, -1/2, or square root 3/2. You'll have a lot of those. So if you do this on a calculator, 1/2 we know is 0.5. What is square root 3/2? Now square root 3/2, compare square root 3/2 and 1/2. They're not the same, right? But my denominators are. And square root of 3 is bigger than 1, right? Because the square root of 1 is 1. And square root of 3 is bigger than the square root of 1. So this is actually bigger, right? So if we look at our graph of 30 degrees, or 60 degrees, right, it's somewhere up here, where 30 degrees is down here, right? So if you look at these points, here's my triangle on this one, and here's my triangle on this one. Now sine is basically our y value, right? And cosine is really our x value. Well, root 3/2 is bigger, so if we look at our x value, right here, isn't this smaller than the height? It is, isn't it? So our x is actually smaller than our y value. So that's why our x is kind of 1/2. And so that's why cosine of 60 is 1/2, because cosine relates to the x, right? And 1/2 is smaller than root 3/2. That's the way I think about it. You don't necessarily have to think about it that way. But these ones I don't want you to do your calculator. I want you to use your reference angle and use your chart to find it. So here's our answer. Here's our answer to the previous one. Okay, on the next one, we're using a calculator to find cotangent of 305.6, but we don't have a cotangent in our calculator, right? But we know that cotangent of an angle is equal to 1 over tangent. Tangent. Maybe I shouldn't do capitals there. Tangent of that same angle, right? So for my calculator here, I'm going to do 1 over tan of 305.6. Right, so I'm going to do 1 over tan of 305.6, and I get -0.716, and so that's my answer. And since we went to 1 decimal here, that's fine. We'll go. I don't really do sig figs too often, but go ahead and just round it to that one. That's fine. Okay, because I think there's 4 significance, so I probably should go out 1 more. I always forget the rules on significant figures. Okay, so now we're finding the exact value. When it says exact value, no decimals, that means no calculator. Okay, so we're finding a tangent of negative 135. So tangent 135, don't enter that in your calculator. We're going to use our reference angle. So we're starting here, initial side, negative 135, it means it opens down, right? Past 90 here, right? And 135, this would be negative 180. Our x-axis to the left here would be negative 180. So it's somewhere over here is our angle. That is negative 135. So what would I need to add to it to get to that 180 there, or negative 180? So what would I need to take 135 and add to get to 180? So that difference is our reference angle, right? So really I can take our reference angle would equal 180 minus 135. So which equals 45. Right, and our reference angle is always positive. So I mean, I could say I need to add negative 45 to this to get to negative 180, and then just take 45 because our reference angle is always positive. Okay, so we're going to use this reference angle 45. We're going to look at, okay, what is tangent of 45? All right, what is tangent of 45? Well, tangent of 45 is 1, right? So tangent of 45 is 1, which is really nice. Because it's x over y, and our x is root 2 over 2, and our y is root 2 over 2, and root 2 over 2 divided by root 2 over 2 is 1. So tangent of 45 is 1, and so we're good there. But what quadrant are we in? We're in the third quadrant, right? So since we're in the third quadrant, what is tangent? Tangent's positive, so tan of negative 135 is still positive 1. So there's our answer. Okay, here's a little word problem for you. You have a guy wire, 74.4 meters long, and it's attached to the top of an antenna, and the antenna mast that is 71.3 meters high. Find the angle that the wire makes with the ground. Okay, so here we have our ground, we have our antenna mast, that's up here, and we have our guy wire that's stretching to the ground, right? Okay, this guy wire is 77.4 meters long, and our height of this mast is antenna mast is 71.3, and we want to find, okay, how fine is the angle? Find the angle that the wire makes with the ground. So the wire makes with the ground. So that would be, here's the ground, right? And here's our wire. So we're looking for this angle right here. You can go ahead and label whatever you want. If you want to label it theta, this is theta. So we want to make, what is that angle that the wire makes with the ground? So the wire connecting to the ground, right? Okay, so we're trying to find an angle, and since we're trying to find an angle, what trig functions do we use? What are those called when we're trying to find the angle? So that is inverse, right? So we're looking for inverse trig functions. So in order to find our theta, we're going to use an inverse trig function, right? Don't know which one yet, so we have to look at what are we given in relationship to the angle that we want. So what is the 71.3 in the relationship to the angle? Well, that is opposite. And what is this angle? Oh, is that adjacent or is that hypotenuse? So this might be a little tricky. That's why you kind of need to draw your diagram. And here you can see my diagram. The right angle is probably down here, right? So that 77.4 is going to be my hypotenuse. So make sure you always identify the hypotenuse in these word problems, right? Even with your regular solving a right triangle, you want to identify that hypotenuse. So which trig function deals with opposite and hypotenuse? Well, that would be sine, right? So I want to do sine inverse of opposite over the hypotenuse, right? So sine inverse of, what's my opposite? My opposite 71.3, and my hypotenuse is 77.4. And that's going to give me my angle. So I put that in my calculator. Alright, so that is, so our theta here, the angle that the wire makes with the ground is 67.1 degrees, okay? So that's our angle, and that's how you do one of those word problems.